Miss, do you understand my explanation or no?
Yes, I got it. So the answer
Exactly.
is
Good.
A.
Very good. Okay. Okay. Let's go to the number 20. 20, 20, 20. 20 is, okay, u square minus 3ub minus 28b squared. Well, to say I take 28, I analyze the factor of 28 is 28 times 1, 14 times 2, 7 times 4, no? It's the only possibility to find two numbers can multiply each other, give me 28, is that factor. 28 is this factor. Now addition or subtraction, one by one, you get 3. It's obvious that the last one is 7 minus 4 is 3. So the combination that works perfectly is 7 and 4. You open two parentheses, you put a variable first, u, and you copy 7 and 4, pero using the second variable que es 7b and 4b. Okay, I need help with the sign. Same or different, who is positive, who is negative, both negative or both positive. Come on, come on, come on, come on.
They are the same, Professor.
No, no, why no? Because this, different, of course, because this sign, okay, remember, I repeat one more time. We have two signs. We have two signs. I call this the first one. I call this the second one. And you analyze the first, it's obvious, right? So now, when the first sign is negative, automatically indicate me that we have different signs. Negative, different. Positive, same. That's different. And the second sign indicate me the sign of the bigger number. Bigger number is 7. And between 7 and 4, what is the bigger? 7. This is a negative and it's a positive. End the story. Clear or confusing?
Professor, I have a question just to make sure. Like when the first sign like is negative, that means it's different, right? But if all the equation like is negative, like normally the biggest like number is negative and the another number is positive, right?
You are right. You get the idea. Okay. Now checking just in case. Your multiplication, FOIL, u times u squared. U times 4b is plus 4ub. Negative 7b times u is negative 7ub. And negative 7 times positive 4 is negative 28b squared. And when you combine like term, remember FOIL have 4 elements. First, outer, inner, last. And normally you combine outer and inner together in order to get, in this case, negative 7 and positive 4. It's obvious que es negative 3ub minus 28b squared, exactly like the original. And this factorization that we found before is perfect. Que corresponde with the option. What option is, I suppose que es C, no? And do it okay? It's C. You correct me, say I make a mistake. I am not good in the selection. Everyone follow me? Everyone understand very well this or no? Yes or no? Confusing, very confusing. Okay, I know. Go ahead. You say something? Okay, suppose the 21. 21 is u squared minus 4ub minus 45. 45b squared. Okay, I take 45. The combination for the 45 is 45 times 1. Another combination is 15 times 3. Divided by 2, no. because 45 is not divisible by 2. When you put in the calculator, maybe 45 divided by 2, you get decimal. That means that 45 is not multiple. By 3, yes. By 4, no. By 5, yes. Que 9 and 5. And two numbers can somehow addition or subtraction give me 4 is this. Because 9 minus 5 is 4. Got it? Okay, entonces I open two parentheses. You put the first variable here, and the second variable participate 9 and 5. Is 9b, and 5b. And what about the sign? Get the complicated part. It's different, it's the same.
Different, Professor.
Who is negative, who is positive?
The 9 is negative and 5 is positive.
Absolutely perfect. Verification now. U times U square. Exactly like that. U times 5b is plus 5ub. And negative 9b times u is minus 9ub. I put in the same order of the original. Well, actually, it's alphabetic order, no? And finally, it's minus 45b squared. And when you combine that term, it's negative 4 u squared minus 4ub minus 45b squared. And we come back at the beginning. This is just for checking. For checking what? For checking this answer. Get the factorization. Remember, we have expression. We are doing the factorization. Break it down in different. And the opposite direction is multiplication. Your multiplication, this guy times this guy, and we come back at the beginning. This is the idea. Any question? Super easy or super complicated?
Easy, Professor.
Easy. Okay. 22 is a little bit hard because it involves a big number. But okay, you use a calculator, no? X squared plus AXY plus, or minus, sorry, 128y squared. So the factor of the 128 divided by 2 divided by 3, but I discover que 16 times 8, let me check it in the calculator. 16 times 8, oh, 128, exactly like that. And somehow 16 minus 8 is 8. And this is the combination. I copy X, I copy 16y and ay. Remember that we are doing problems that contain two variables. I see that this sign is negative, thus we expect the different sign. The big one is positive, and the small is negative. Now check it. X times x, x squared. X times negative xy. 16 is plus 16 xy. And finally is the big number, get minus 128. It's multiplication 16 times 8 y squared. And when you combine that term here, it's plus xy minus 128. And we come back here at the original trinomial. Therefore, this factorization is perfect. Que corresponde with the option, let me see. I suppose que A, no? Yeah. Any question? Look like easy or complicated?
Now it looks easy. Professor, I have a question. Can I ask you a question, Professor? I saw that our homework is due on 14, right?
Well, no, I can extend it. Remember, we have one day of delay for the. Entonces, no, I can. Okay, it's good that you remind me. Okay, send me email to remind me. Okay.
Okay, Professor.
Okay, no problem. Okay, now let's start the complicated part. Remember, I explained at the beginning, okay, in the trinomial topic, we have three kinds of trinomial: regular, Okay, the regular is the thing that we are doing now. Okay, but we have complicated. And we have also perfect square. Okay, the example that we are doing before is regular. And the complicated I want to discuss it now. For example, 23. 23. 23 is 12 x squared plus 17 x plus 6. Okay, how you recognize que es complicated? Ah, because the coefficient in front the first is no 1. Do you see, notice que the problem that we are doing before, suppose I pick 1, 22, is x squared plus x plus 8 xy minus 128 y squared. You see that this coefficient is 1. When the coefficient, when the leading coefficient is equal to 1, immediately you recognize it's regular. And this is super easy. When the leading coefficient is not 1, it's different to the 1, so it's complicated. And complicated we are doing a little bit different. No, it's super complicated, but it's a little bit different. So we have two different methods for solving this. Okay, I prefer one I want to explain now. Entonces, in another example, I want to explain another way. But frequently, I suppose que 99% of the time, we are doing in that way. And that way, que es like factorization by grouping. Do you remember about factorization by grouping that we covered before? By grouping. Bueno, professor, you explain me que factorization by grouping is applied when you have 4 guys. Okay, you find the GCF in the first couple and you find the GCF in the second couple. However, we have no 4 guys, we have 3. 1, 2, 3. It's trinomial, no? It's trinomial. Hello. Okay, so we are doing this idea. Look, your multiplication, this number always, and this number, the first one and the last, and you put it in a calculator. That's a 72. And you analyze, you focus in the factor of 72, que somehow give me 17. Y ahí discover que 9 times 8 is 72, so 9 times 8 is 72, and somehow 9 plus 8 is 17. Oh, entonces this is the key, open the door in this example, 9 and 8. Okay. And this is the most important moment. You copy the first, exactly the same, 12x squared. And you copy the last, exactly the same, que 6. And you break it down 17 using 9 and 8, like that. 9x plus 8x plus 6. Okay, basically this expression is perfectly equivalent to the original. But what is the only difference que have this? Okay, in the original we have trinomial, and the new one, que is equivalent, we have 4 guys, and you apply factorization by grouping. This is the idea. So what is the GCF in the first couple? What is the GCF in the first couple? Okay, the GCF in the first couple, let me see. 12 is 3, no. Let me try to do well. 2, 6. Wait, but I want 9x. Okay, the idea stays the same. You need to find 2 numbers that multiply, give me 72, okay, maybe it's 9 and 8. We have another, no? But somehow addition or subtraction, but subtraction doesn't work because when you subtract 1, I need 17, que es the original meat terms. Okay? This is your question, mister? Do you understand the idea or no? A ver, a ver, a ver. Okay, activate the microphone. Do you understand the idea? Yes. I am a girl. Okay, Bianca. Bianca, do you understand or no? Okay. Now focusing and factorization by grouping. Okay, let me repeat again the idea. The idea is, number one, I face a complicated trinomial. How you recognize que es complicated trinomial? Because the coefficient in the first is no one. Good. Immediately I multiply the first number and the last number. Give me 72. Okay, and try to find the key to open the door. Okay, 72, we have different factors. Well, 72 is divisible by 2, que es 36 times 2, no? 18 times 4. Oh, I continue with the calculator, no? 72 by 6, no? By 9 or by 8 is 9. However, I need to find the combination. The combination is this. Because they are connection. 8 and 9 together, when you're adding a 17. Perfect. This couple of number help me to break it down, this 17 and 2. And to say, actually, in that moment, we have two couple. And it's a classical factorization by group. Wow. Okay, entonces the GCF and the first couple, bueno, I suppose que es 3, no? Okay, let me practice that part. 12 divided by 2 is 6, 2, 3. 9 divided by 3 is 3. Okay, 3, at least 3 is a common factor. And the numerical part. And the variable part, x. Okay, so we have 4x plus 3, no? Okay. And what is the GCF in the second? Well, it's 8 and 6. A is 2, 4, 2, 2, and 6 is 2, 3. Oh, 2 is a common factor. Only 2. X no. Nuela. Entonces es 2. Es 2. Entonces we have 4x plus 3. Okay. In this moment, look at my face. This is my face. I am happy. Why I am happy? Because the factor 4x plus 3, is the common factor. I factor out one more time. I open last parenthesis. And the last parenthesis stay 3x and these two. End the story. And this is my, well, I know, my potential solution. Potential solution of factorization. Now you select, you go directly immediately to select one option. No, you have to FOIL and verification. FOIL to verification. You multiply 4x times 3x is 12x squared. You multiply 4x times 2 is 8x. The multiplication 3 times 3 is 9x. And multiplication, this is 6. And when you combine, like term here is 17. Exactly like the original. Therefore, the answer can enclosed in the box is the solution. No potential, sino solution. I select the option, option C, I guess so, no? Let me see, yeah. Do you understand the thing I call complicated, but it's not complicated. It's a little bit more.
Can I ask a question, Professor?
Go ahead.
Professor, I have a question. For example, when it's regular, we focus.
Yeah, I don't understand anything. Okay, speak. Try to put closer to the microphone because I hear echo.
Sorry, Professor.
No, it's okay. Go ahead.
Yes, Professor. My question to you is, for example, when we don't have coefficients on X, we focus on the second number and the third number. But in that exercise, we focus on the first one and the last one.
Yeah, absolutely, bro. Yeah, your multiplication, the first number always time the last number. I say more, regardless the sign. Regardless the sign. Si the sign is negative, I don't care. You take the first number and you take the second number and multiplication each other. Hi, Professor, I was able to log in Skype. Okay. Okay, your multiplication, this. And when you get this multiplication, you try to find the key to open the door. The key to open the door is two numbers, get multiply, give me 72, and somehow when you adding or subtracting, give me 70. This is the key to open the door. It's similar, but not exactly the same. Entonces we need practice. I recommend you see more examples, 24, 25, until little by little you get the idea, right? Right or no? Noela?
Yes, Professor, yes.
Uh-huh. Okay, the lady can say you have a question. Come on, come on.
Yes, LaKenya. How did you get 3x plus 2? I know how you
Okay, good question.
square.
Excellent. I like this question. Yes, when you factorization, this factor, can you see it's the same? Look, this guy and this side is the same. Yes or no? I put out.
Yes,
I put out. I put out. This go out. This go
okay.
out. Uh-huh. Now, I copy again here. I copy again here. Okay. You see now?
Yeah, I see it.
Excellent. Entonces, beautiful. Entonces, stay in the last paréntesis, 3x, que es this. And this 2, que es this. Super?
Yep, I got it.
Okay, super. Let's go to the 24 problem. 24 problem. 24 is 6y squared plus 13 y plus 6. Oh, immediately I identify that we are in front of the complicated trinomial because we have factor here that is not 1. See, this factor is 1, it's regular, it's easy. Not necessarily doing in this long way. No. We are doing in one shot. But in this case, no. In this case, you multiplication, this guy and this guy, que es a coincidence que se saying 36. I need to find the key to open the door. I need to find two factors of 36 somehow give me 13. 36 times 1 is 18 times 2 is 12 times 3 and is 9 times 4, no? Divided by 5, no? Divided by 5 is and 6 times 6. And 9 and 4, right? And 9 and 4 because 9 plus 4 is 13. Do you see how I find the combination? And the combination is 9 and 4. 9 and 4 is the guy that can help me to break it down this trinomial in 4. So say I just copy, bring down the first one. And the last one. And 9 and 4 and 9y plus 4y plus 6. In this case, we have 1, 2, 3, and 4 terms. Now it's ready to apply factorization by grouping. And you find the GCF in the first couple, and you find the GCF in the second couple. The GCF in the first couple is, who helped me with the GCF in the first couple? It's 3. It's only 3 or 3y? Okay, you need to analyze, Noela, not only the coefficiency plus variable. It's 3y, no? Because in between 9 and 6, look at that. It's clear I get 3. It's clear I get 3. But in between y squared, que es y times y, and y alone, que es just y, is common y. 3y. Open parenthesis, we have 2y plus 3. And what is the GCF in between 4 and 6?
2.
2y plus 3. I am happy because 2y plus 3 is common factor. Open the last parenthesis, inside the last parenthesis we have 3y plus 2. In the story. No. In the story, no. Mandatory, I need to verification. Mandatory, I need to go backward. And verification that this is, because sometimes doesn't work. I guarantee you, no, it's not frequently, it's seldom it happens, but it doesn't work. And your multiplication, 2y times 3y, 6y squared. And doing the multiplication, this and this, no? I'm doing a multiplication, this and that is 4y plus. Now multiplication this and this, 9y. And the last one is 6. When you combine, light turn here, 30. And we come back exactly to the beginning. Therefore, the factorization is good. It is good. Any question? I lied. She lied. Are you crazy? Okay. 25. 25. 25. 25. 25 is 9z squared minus 6c minus 8. Okay. Again, we have in front of the complicated trinomial because the coefficients here is 9. When there's no 9, is 1, it's regular. A multiplication this number times this number. I don't care the sign. The sign is totally irrelevant in this step. Your multiplication, 9 times 8, 72. Okay, and you analyze the factor of 72 que somehow give me 6. 72 is divisible by 2, get 36, no, 72. I put in my calculator, guys. I take, cool down, relax, 72 divided by 2 is 36. Divided by 3 is 24. So, entonces 24 times 3, no? Yeah. Okay, 72 divided by 4 is 18 by 4. I'm checking just in case one by one. When you addition or subtraction, give me 6. I suppose que not yet, right? Entonces 72 divided by 5, no. By 5 is impossible. By 6 is 12. Ooh. By 6 is 12. Okay. I'm by 9, by 8 and 9, no? 9 and 8 is also 72, no? But I suppose, okay, this combination doesn't work because when you're adding a 17 and when you're subtracting a 1. However, this when you're subtracting a 6. This is our combination. Our combination is 12 and 6. Everyone follow me?
Yes. Yes.
Okay. Now, what is the next step? Bring down the first. Bring down the last one with the corresponding sign, of course, as negative 8. And separate negative 6 using 12 and 6. Be careful. Be careful with the sign. It's minus 12z plus 6c. Just in case, I want to verification backward. Okay, when you combine negative 12 and 6, you subtraction. And 12 minus 6 is 6. And put the sign of the bigger number as negative. Exactly the same we have here. Therefore, this expression can now contain 1, 2, 3, 4 is equivalent to the trinomial, the original trinomial, can contain only 1, 2, 3. Okay, now factorization by grouping. Ready by grouping. Grouping this couple and grouping this couple. What is the GCF in the first couple? What is the GCF in the 3Z? Very well. Very well. When you find the GCF, don't forget the variable part. Numerical is 3 and C is common. Factor out. We have C minus 4, no? Let me check in just in case. No, 3 here. Because 3 times 3 is 9. C times C is C squared. 3C is minus 12C. Okay, super. And what is the GCF in the second? 6 and 8. It's 2. 3C minus 4. I am happy because I can see that 3c minus 4 is common. I repeat again, I factor out, open the last parenthesis. In the last parenthesis, we have 3z plus 2. Okay, and closing the box because I suppose that this answer is correct, but I cannot suppose. I need a verification. Okay, you multiplication, you go backward. 3c times 3c, 9c squared. 3c times 2 is 6. C. This is minus 12. C. The negative 4 and positive 3. And negative 4 and is negative 8. And when you combine like term here, opposite sign, subtraction, is 6. C, pero negative. You put the sign of the bigger number exactly the same to the original part. Okay, this is the checking. Okay, this is not strictly mandatory. Well, for me it's mandatory because sometimes fail and sometimes happen we have two combinations and one combination is good. Okay, there are a lot of, so you need to verification. It's important verification. Okay, one more.
Professor, we move on to the next question. Professor, how like find the 12 multiplied by 6? How?
Bueno, okay. I take my calculator. This is my calculator, miss. Somebody call me by phone. But I am teaching. Okay, look. I put in my calculator 72 divided by 2 and press enter. Okay, you get 36. So you be patient and you divide by 2 and you divide by 3 and you divide by 4 and you divide by 5. No, because 5, well, you divide, but when you divide by 5 you get decimal. It's wrong. It's not divisible by 5. And you divide by 6 and entonces simultaneously you check it. Addition is 38, subtraction is 34. You need to get 6. So now, little by little, you approach it to this combination. Okay, it's when you divide 72 in the calculator, divided by 6, get 12. And you check it. 12 plus 6, 12 plus 6, 18. No good, because I need 6. And 12 minus 6 is 6. Oh, this is our combination. So I put here 12 and 6. Do you understand? Do you understand? Okay, this is a process. So the most complicated thing, in my opinion, is finding.
It's prime composition. Am I right?
Yes. Okay, this, in my opinion, this is the most complicated part. But you relax, you be confident, because you find the combination. Pero tú say now, how you find the combination? Don't cry. Look in the ceiling. God, give me the combination, please. No. You take the calculator and you divide it by 2, divided by 3, divided by 4, divided by 5 when it's possible, divided by 6, divided by 7, and addition and subtraction. Let's go to the 26. 26. 15 c squared minus 4 c minus 4. Okay, I realize that we are in front of the complicated trinomial because 15 is the leading coefficient, no 1. And your multiplication, 15 times 4 is 60. Remember, I don't care the sign. The sign do not participate in the multiplication. So 60, and give me 4. Wow, I am totally lost. 60 is 60 times 1, 30 times 2, 20 times 3, 15 times 4. By 5 is 12, no? 12 times 5. And by 6 is 10 and 6, no? Divided by 7, no. Divided by 8, no. And so on. Okay, this is the combination. So I put in my calculator 1, 2, 3, 4, 5. In this case, divisible by everything. But I need to find 4. And the only combination, in my opinion, work is this. Because 10 minus 6 is 4. Correct? Okay, now ready. Ready to separate, break it down 4 using 10 and 6. I copy 15z squared. I copy 4, minus 4. And now it's minus 10z plus 6z. Because when you combine minus 10 plus 6 give me negative 4. It's exactly the same sign we have here. Negative. Ready grouping. Ready grouping. What is the GCF in the first couple? What is the GCF in between 15z squared? GCF. F5. But 5 numerical part. And what about variable? 5z. Okay. We have 3z minus 2, no? Okay. And what is the GCF in the second, in the green part?
2.
2 out. 2 out. 3z minus 2. I am so happy. 3z minus 2 is a common factor. I factor out. Open the last parenthesis. 5z plus 2. Okay. And this is the solution. Okay, suppose it's good. But just in case, I need to verification. And multiplication. 3z times 5 is 15z squared. First, outer is 6z. Inner is negative 10z. And last is negative 4. And when you combine like that here, it's obvious it's negative 4. See, exactly like that. Therefore, this factorization is good. I select the option, let me see, 3c, 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 3c minus 2. I suppose it's D. Okay. Very good. Very good. Noela.
Yes. Good.
Let me ask a question. Do you miss Ingrid?
Yes.
Me too. Me too.
I've been quiet today. I've been quiet. I'm listening.
Yes, Kenya is talking today.
How you stay quiet? How? Because you understand very well everything?
Yes.
Wow, amazing. Good.
But I was driving. I was there all the time.
Nice. It's the miracle of the technology. You driving and also you see the lecture. Okay. Okay. That was 26, no? Now 27. 27 bring me new surprise. 27. 27 is 5 m squared plus 39 m plus 54. Okay. So now, well, okay, no problem. I multiply that number and that number. Why not? I know that this rule, 54 times 5. Wow, 270. Okay. Recommendation. When the multiplication of this number is greater than 100, this is a little bit crazy to find the combination. Therefore, we are using another way, another completely different way. Okay, let's call it this. Okay, the first way is factorization by grouping, no? However, this is not a grouping. This is try and error. Try and error. Why is called try and error? Because maybe it's guessing. But guessing is smart. Let me show you. You take the first, and you take the last. Separate. 5m squared. Okay, it's nice because 5 is a prime number, and the only combination that this situation happen is that you have 5m times 1m. There are no more combination. Because 5 is prime. Si es 12, entonces there are several combinations. And 54, no. 54, we have several combinations because 54 is divisible by 2. So 54 times 1 is one possibility. 54 divided by 2 is 27. So 27 by 2 is 54, huh? 54 is divisible by 3, I guess so. It's 18. 54 is divisible by 4. 54 divisible by 4. Ah, no, it's decimal. By 4, no. 54 is divisible by 5. 54 divisible by 5. Ah, no, it's decimal. No good. And 54 is divisible by 6. 54 is divisible by 6. Oh, and 9. Okay, entonces one combination is 9 and 6. Okay, okay. Now, this is a moment to guessing. And this is consuming time because you don't know what is the combination. You need to matching. This combination is the only one that we have, fortunately. But we have 4 options here. 4 options here. Entonces, well, I select the first one, the second, the third, the last, I don't know, and you check the verification. Doesn't work. Second, doesn't work. Third, doesn't work. This is try and error. Try and error. I know that the answer is using this. So I can only do done was time. I select this and this. So you select, look, you select 5M. M and 1M, no? Just M. What is the reason I copy 2 times? Because I permutation. I put 9 here, 6. The combination I try to verification and 6 and 9 because we have 2 possibilities. Okay. And you multiply. Multiply how? Multiply like the FOIL, but no. Only I need outer and inner, like that. Boom, boom. When you multiply 5M times 6 is 30. M. When you multiply 9 times M and 9M. Addition is 39. M. Wow, exactly the same here. Maybe this is a good candidate to be. Okay, suppose I start for this. Multiplication is 45. M. And multiplication here is 6. And when you add it, 51. No 39. And no subtraction because every sign in the my trinomial is positive. It have no sense to seek it. One guy is negative. Everything is positive, right? Everything is positive. So the combination word, in my opinion, is the first one. But I need to verification. Mandatory. My proposal is like that. Okay. FOIL. This time that. 5M squared. This time that. 30. This time that. 9. This time that. 54. And when you combine like term, 30 and 9 together, 39. Okay, entonces you say, oh no, professor, how do you know that the combination word is this? Well, I don't know. I tried the first one and doesn't work. I tried the second and doesn't work. I tried the third and doesn't work in the last word. The problem is I don't do that because I don't want what's the time here with you. It's too long process. So my recommendation is try to avoid try and error. We only using try and error when the multiplication this number is greater than 100. Otherwise, no, it's wrong. Not wrong, but it's completely useless. Okay? Bueno. Some people, some students, some teachers like so much try and error. I'm only teaching try and error. Good. Okay, no problem. And you say, well, but this is stupid. No, it's not stupid. I find the combination quickly. Okay, I respect this. Okay, entonces, my recommendation, you multiply the first number and the last number. Si the answer is acceptable, it's less than 100, 72, 81. Okay, I apply the factorization by grouping, no? Que es the thing we are doing before. In this case, the answer was 200 something. No, this is crazy doing by, because it's too hard to find the combination. Entonces, you apply, try and error. But this is the last option, in my opinion. Okay? Okay? You understand or no? A little bit confused, right? I suppose in the test, no. I don't put try and error. Any problem is solved by. I suppose. I don't remember very well. Okay, let me explain 28. And 28 bring me completely new situation. Bring me completely new situation. It's 81 x squared minus 128 x plus 49. Okay, this is classical perfect square. Trinomial. And some people don't remember this idea. And some people multiplication 81 and 49. Wow, it's a big number. Big number. And to say, no, it's try and error. To say you break it down 81 in a stupid factor. No. Okay. This is it's possible to find it. Yes, it's possible. But you consuming a lot of time. You waste the time, and the time is important. And how you recognize that this trinomial is perfect square? The clue is that the first number and the last number are perfect square number. Perfect square number. Because the square root 81 is 9 and the square root 49 is 7. If this number is not perfect square, automatically you say, no, this is not perfect square trinomial. Entonces I need to do for the long way. You spend maybe 1 week doing that problem. Okay, and this is enough? No. One more condition. Condition number 1 is both numbers are perfect square. Condition number 2 is, can you multiply 9 times 7 multiplication times extra additional? I want to explain why this, where come from these two. And when you multiply 9 times 2, 9 times 7, times 2, the answer is exactly 126. It's exactly the same. And it's the confirmation that this trinomial is perfect square. So 2 steps to prove it's perfect square. Number 1, the number involved in the problem, the first and the last, are perfect square number. Secondly, multiplication 9 and 7 together times extra 2 is exactly the same in the middle term. Let me try to explain why extra 2. Okay, let's using only variable. Suppose a plus b is square. So a plus b times a plus b. This is theoretical part to explain what is the reason que extra 2. When you fold this, a squared plus ab plus ab again, look, when you multiply this and this, ab in alphabetic order, and b squared. And when you combine that term, in this case, they are identical, yes, twice, ab. And this is a classical example of the perfect square trinomial. The number in the first position and the last position are perfect square number. Is square root a squared is a. Square root b squared is b. And the middle guy is the multiplication both. And extra 2, look at that. And this situation happened perfectly in our example. And the factorization, by the way, they are twin brothers. Twin brother a plus b times a plus b. Oh, more condensing in that way. And this is a super elegant answer. You copy in only one parenthesis because it's a perfect square trinomial. And the number inside here is 9x. Where come from this? Oh, square root. Square root 81 x squared is 9x, right? And square root 49 is 7, no? It's square root this is 7, entonces 7. And the sign in the middle is negative. Because I suppose that they are two twin brother factors. This sign is positive, therefore we have the same sign, que es negative both, because it's negative. When you condense it in only one, because they are twin brother, you can write more elegant in that way, 9x minus 7. End the story. End the story. And you need to verification? Yes, you need to verification. Let's do it quickly. So you foil. 9x minus 7 times 7. 81 x squared minus 63 x minus 63 again. Okay, a repetition because they are twin brothers. Plus 49, que is 7 times 7. When you combine this, it's minus 126 x. And this is the confirmation that this factorization. This is the elegant way to put a square. Lie. Option D. Any question? Any question? Any question? You know, this is not frequently happen. So the perfect square trinomial is very, very weird. It happen, but you need to be aware for this moment. You need to be strategy. Yes. When I finish the topic of the factorization, every case, I want to explain the strategy. Can you face the problem of the factorization? And also, we are doing miscellaneous problem can involve several techniques of the factorization together, right? But fortunately or unfortunately, we explain now one by one, okay? Trinomial, we have the regular, piece okay, super easy, the complicated, little bit different, and the perfect square trinomial. Let's do in 29. 29 is another classical problem of the trinomial factorization. 29 is 4. 29 is 4x squared minus 9x plus 3. Okay. It's perfect square. I don't know. Let me see. Square root 4x squared is 2x. Yeah, because 4 is perfect square. Pero square root 3, no. Entonces no perfect square. Forget about this idea. This is a complicated trinomial. Yes or no? Yes, because the coefficient here no 1. Entonces your multiplication 4 and 3. It's 12. Oh, 12 is acceptable. 12 is acceptable. And what is the combination? The combination of 12. The combination of 12 is easy. It's 12 and 1. 6 and 2, no? 3 and 4. 3 and 4. Okay? This is the combination for the 12, the factor of 12. But when you adding or subtraction, I need 9. And when you adding, this is 13. When you subtracting, it's 11. When you adding here, it's 8. When you subtracting, it's 4. When you adding here, it's 7. When you subtracting, it's 1. Yeah, I need 9. And 9 is not here. No 9. Therefore, what is the answer, professor? Well, this trinomial is impossible. Factorization. And when it's impossible, it's called a prime. Entonces, the option B. You try to do your best. You investigate the factor. You investigate their combinations. And doesn't work any combination because 9 is crazy. Another situation different happen. See, this number is 8. Because 8 belongs to the solution. But no, it's not 8, it's 9. Therefore, not always happy. Not always any trinomial is possible to factorization. No, sometimes no. I promise in the test I never put this situation. Because my goal is that you are doing the factorization. Well, okay. But you need to be aware, because in Alex, maybe you need to say, no. This trinomial is impossible factorization. And this is called private trinomial. Everyone follow me? Are you boring? What is the time? We have 10 minutes. Okay, are you boring? No. Okay, good. Let's move on to the 30. Well, in 30 is different objective. And 30, factor the trinomial that is perfect square. So this is supposed to say you need to verification. See, the trinomial is perfect square. Let's practice a little bit. Perfect square. Okay, let me explain the rule. The rule is super easy. Look, the rule is super easy. The shortcut to do in 1 second. Okay, the square root this guy. So this arrow indicates square root. Is x. Because I know the square root x squared is x, no? And the square root, the first and the last, square root 100, is 10. Okay, and you multiply this guy times extra 2. Remember the idea for the extra 2 is 20x, exactly the same we have here. So yes, the conclusion is it is a perfect square trinomial. And the factorization, wow, it's super easy, because I know that when it's perfect square trinomial, the factors are twin brother. Okay, and twin brother you can represent separately if you want, but not necessary. And you copy here x, que es this x. You copy 10 here, que es this 10, and always plus here, que es this sign. Because on the perfect square trinomial, this sign is always positive. Si es negative, no, it's not perfect square. It's equivalent to say x, 10, plus. So we are doing like a regular, if you want, because the coefficient here is 1. But okay. I want to explain this test. This is the test of verification. Quickly, in 1 second, that the trinomial is perfect square. Do you understand the idea or no?
Professor,
Go ahead.
I know we have square, but of that one.
Wow, too much echo.
Sorry, Professor.
I don't know si es que you need to go farther than the microphone or close to microphone or speak slowly, or I don't know.
When you hear
When you hear me or test, Ingrid suggest you typing in the, but sometimes it's complicated to express the idea.
yes, it
A lot of echo. Okay. How are we solving the problem? Speak slowly.
okay,
Like professor. Come on.
yes, Professor. I wanna know if we solve the problem one instead of
Yes.
perfect.
You are right. Okay, another interpretation of this problem. The problem is that when I read the question talking about perfect square. So that is the reason I try to solve it. But okay, look at that. Suppose I don't care anything. Yeah, I realize, wow, this is regular trinomial, right? Easy, because the coefficient here is 1. Entonces, no, I don't care, perfect square, no. I open two parentheses directly, I put a variable x. Yeah, I try to find the combination. Two numbers can multiply, give me 100, and addition or subtraction is 20. It's obvious que es 10 and 10. Because 10 times 10 is 100, and 10 plus 10 is 20. And what about the sign? Same sign plus both. Bam. I finish. I see. I don't say in the moment. This guy is perfect square, because the professor say that when they are twin brothers, it's perfect square. So you put together, and that's it. But this answer is perfect. This is more elegant answer, but it's perfect. The blue one is more elegant, but it's perfect. Okay. Ajá, super. Okay. Nuela, I don't understand very well, pero si I understand a little bit your information, I suppose my experience like a teacher, give me the intuition, no? Okay, okay, okay. This was the question. Let's move on to the 31st. 31st is x squared minus 16x plus 256. Bueno, I can do like a regular trinomial or I can do like a perfect square. Suppose que I'm doing by perfect square. You apply square root. The square root of the first y square root of the last. The square root of this guy is x. The square root of this guy, I put in my calculator, is 16. And when you multiply 16 times 2 times extra 2 is 32x, que is not exactly the same of this. Therefore, the answer is no. A perfect square trinomial.
How do you know it's not a perfect? I'm sorry.
Remember I prove what is the reason of this additional 2. Remember when I find the formula of this is a squared plus twice ab plus b squared. Do you remember this idea? Do you remember, miss? Yes or no? Come on, answer me. No. You don't remember. I explain here now. But no, don't worry, I explain again for you.
Thank you.
When you multiply a plus b times a plus b, when you FOIL this.
Okay.
Do you see? Okay, entonces to prove the shortcut, to prove in 1 second si one trinomial is perfect square or no, you find the square root of the first y the last. You multiplication each other, you include extra 2 because this 2 is this 2, and see this answer is exactly the same of the middle term, it's perfect square. The answer is yes, but the answer is no in that case. Good? Good?
Yes.
Good. Thank you. Let's move on to 32. 32 is the same idea. We have b squared minus 34b plus 289. Okay, I try to apply the test of the perfect square. Square root this guy b, and square root this I put in my calculator because I don't know by memory. Square root 289. The answer is 17. And when you multiply 17 times b times extra 2 is 34. It's 34b. It's exactly the same. The answer is perfect square or no? The answer is yes or no. It's perfect square or no?
Yes.
Yes. The answer is yes. Now extra, complementary. Entonces, what is the factorization? Bueno, si I know que this trinomial is perfect square, the factorization consists in only one factor because they are twin brothers. I can condense it in only one. So in the first, I put this guy, b. In the second, I put this guy, 17. And the sign in the middle is minus, que this minus. Final answer. Okay, corresponding with the option C. One more, the last one. 33. And that's it. 33. 33 is m squared plus am plus 16. Square root this is m, square root this is 4. Multiplication this and this, and extra 2 Is it AM? Yes, it's perfect square. And the factorization is M4 square and plus. Final answer que es de option D. Everything okay? Everything okay? Okay, I know. Guys, let me explain something. The factorization topic, I understand, is very, very hard. I told you, but it's important, extremely important. I have students in college algebra that don't know very well factorization. So I need to repeat again factorization. It's going to be extending. Extending for what? The test is Sunday. No, don't worry. No, Sunday no. ¿Qué carajo Sunday? Sunday no. Sunday is holiday. Okay, Sunday is weekend. I extend it to the next week. Okay, because you relax. We take the test when you finish the chapter. And finish the chapter plus review. Now, the extension for the Ale, Nuela, you propose me something or no? Okay, it's due 24, no? 24. I don't know. I need to check in Alex.
No, Professor.
What day is due the test online? Eh? I don't understand. Typing it. 14.
Test is on the 14th.
And 14 is next week, no? Okay, today is 9, no? Today is 9. Let me see in the calendar. Wait. Okay, today is 9. In the calendar, I can see today is 9. 14, no. Hello. 14 is Sunday, no. Okay, I suppose we have 11. We continue doing this package. 16. We continue. No, we finish this packet, but I start review, and I spend 16 and 18 for the review. Now 23rd would be the test. Okay, so I fix it right now. And Alex, when the class is over now, I go to Alex, I fix it 23rd. It's the due date for the test 3 online. And online and on paper, both. Okay? I suppose that I sent, and homework, no, yeah. Everything is due now. Let me copy in one piece of paper. Okay? 23rd. 23rd is due both. Homework and test. Online and test. Okay, so I will say, so we spend 11, finish this packet, maybe we start review, maybe. I don't know. Okay, guys. Don't worry.